45 to the power 7 equals 15 to the negative y. Find the value of x and y. Okay. When in doubt, go with your prime bases. So convert things to prime bases. So this would be 3 to the power 2x. 45 is 3 squared times 5 times 9. 9 times 5, obviously, to the power 7 equals 15 to the negative y. And 15 we can also write as a prime base, actually. So let's do that. So 15 as prime bases is 3 times 5 to the negative y. So what we have is 3 to the power 2x over 3 to the power 7 times 2 is 14. 5 to the 7 equals 3 to the negative y. 5 to the negative y. Okay. So if we get rid of this fraction on the left, we would have 3 to the power 2x minus 14 times 5 to the negative 7 equals 3 to the negative y times 5 to the negative y, which is great because this is an equation. This base 3 and its exponent should be equal to this base 3 and its exponent, because what we have on the left should be equal to what we have on the right. And this 5 to the negative 7 must be equal to this 5 to the negative y. So we link up the like bases. So if I start with the 5s, 5 to the negative 7 equals 5 to the negative y, which means that y is equal to positive 7. And so if y is equal to positive 7, we can now use that to solve for x, because we've got 3 to the power 2x minus 14 equals 3 to the negative y, but we've just established y as 7. So we'd have 3 to the power 2x minus 14 equals 3 to the power negative 7. And so now that my bases are the same, I equate my exponents. 2x minus 14 equals negative 7. And then inverse operations, I will add 14. So 2x equals 7. So x equals 7 over 2, or 3.5. Right, so I hope that's what your memo says. Otherwise, I've just made up a whole bunch of nonsense. But that's how I would do it.
Okay, ma'am. Let me quickly check the memo.
So, guys, just while we're on here and while Lorato's checking, so whenever you get questions like this, if you don't know where to start, particularly when there's exponents, start with prime bases. If you get your prime bases or get your bases to be prime numbers, 9 times out of 10 is going to give you what you want. Right, so I've also realized I haven't actually answered the question, because the question said determine the value of x plus y, so that would be useful. So that would be 3.5 plus 7, which is 10.5.
I was just about to add that, ma'am. But yes, the memo did say this, so your answer is correct.
I'm correct or incorrect?
Ma'am, you are correct.
Oh, gosh. Great. Okay, well, there we go. That was a nice question. So oftentimes when you get stuff like this, go for prime bases, and 9 times out of 10 is going to get you where you need to be. And like you can see in this one, the prime bases helped me because I ended up having the same bases on the left as what I had on the right. So then I could start actually working with my equation. Good question. So guys, if any of you want to screenshot it, there it is. Otherwise, I'm going to go to our sequences and series. All right, and hopefully that proves to you. Granted, I know I'm a maths teacher and I've been doing this for years, but I mean, I had no idea what this answer was going to be, but I knew where to start. And oftentimes with problem solving, that's half the hurdle to overcome. Once we know where to start, the rest becomes quite easy. Alrighty, guys, but let's get into it. So we are on our fourth bootcamp already, which is wild. We're here at sequences and series. And so in terms of our paper 1, we are on the next second biggest section, which number patterns, sequences and series counts 25 marks. Remember, your 2 biggest sections is functions and calculus, then algebra and number patterns, and then finance and probability. Those are your smaller sections. So that's why on Monday we're doing those 2 together, because they are quite small. All right, but number patterns, the trick with number patterns is going to be your just having your formula sheet and knowing your formula sheet, being able to work with it. And these are the formulas that we need to know. I fully realize I could have just copied and pasted it, but here we are, we're living this life. So firstly, there's 2 types of number patterns where we have formulas that we need to use. So we've got the arithmetic, or arithmetic, however you want to say it, and you've got your TN formula. Now remember, your TN formula allows you to determine the value of a term in your sequence or your series. And we've got our sum formula, which allows us to add up multiple terms in our series. Now again, guys, these are on your formula sheet. You do not need to know them. They are given to you. So that's your arithmetic or arithmetic, however you want to say it. And then we also have our geometric patterns. Right. Geometric patterns, again, 2 formulas. You've got your TN formula to find a specific value of a term. And then we have our sum formula. That's an R, just a weird looking R, I apologize. As well as for certain geometric series that are converging a sum to infinity. Again, all on your formula sheet. All right, so can anyone tell me what the defining characteristic of an arithmetic number pattern is? Oh, sorry, Camilo, I see your hand. What's up?
Ma'am, could you please explain for the sum formula for the geometric, there's about 2. With this, I think one of them is 1 minus R and the other one is the one that you wrote there. Like, when do we use the other one?
It doesn't really matter. So it depends when your R value is, hang on, let me get my words right. Depending on what the value of R is. Obviously now I'm panicking about the other formulas. Let me just pull that other formula. So it doesn't really matter. I would just use the one that's given to you on your formula sheet. However, the other one, I think you might be thinking of just the normal sum formula, because the normal sum formula, so this one over here, is Sn. Sometimes we have it as 1 minus R to the n over 1 minus R. And this is generally, I can't speak today, generally when R is a fraction. It's a terrible one, I do apologize. So I would just use the ones that are given on your formula sheet. You're not going to go wrong. Like I say, the variation is with the sum formula, and it's where your terms swap. And like I say, it's generally if your R value is then a fraction, but it doesn't actually make a difference. And so rather use what you're given so that you know you're using the correct formula, rather than trying to use a formula that maybe you've kind of half worked with and copy down incorrectly, and then you're using the wrong formula. So these over here is what's given on your formula sheet, and I would just work with those. It doesn't actually make a difference. You can use either form of this formula. It's really up to you. So if you want to use the other one, that's fine. But it's really just when R is a specific value, but the formula that you're given on your formula sheet works. So no need to learn the other one. But like I say, you can if you want to. It's not necessary to know it. Does that answer your question? Sorry, I know that was a lot of words.
Yes, ma'am. Thank you.
Okay. So just with sum to infinity, just remember that this is only when your R value is between -1 and 1. That is what a converging series is. So if your R value falls between -1 and 1, then we would be able to find the sum to infinity. But otherwise, it's just your normal sum formula. Right, so my question was, what is the defining characteristic of an arithmetic series? So what makes an arithmetic series an arithmetic series? How would you identify that it is one?
Ma'am, an arithmetic sequence. You can see a common difference. Coronally, there's a one common difference.
Perfect. Okay, good. Nice. And I see it all coming in on the chat there, guys. Well done. So it has a common first difference. So basically, we add or subtract the same value each time to get from one term to the next. Perfect. What is the defining characteristic then of a geometric sequence or series? Toriso?
Then it has a common ratio.
Excellent. Okay, this geometric has a common ratio. That's what the R stands for in our formulae down here. And then the other pattern that we, or sequence that we work with is quadratic. Now, we don't work with the sum in quadratic sequences, but we do work with the actual sequence. What is the defining characteristic of a quadratic sequence? That's right. So there's a common second difference. And really importantly, what that means is that your first differences form an arithmetic or linear pattern. And this is often something that's asked of us, and so it's important for us to know. All right, so common second difference for quadratic, common first difference for arithmetic or arithmetic, however you want to say it, and geometric has a constant or common ratio. Right, just quickly for quadratic, if we ever need to find Tn, we just need to remember that Tn, because it's a quadratic sequence, will take the form of Tn equals an squared plus bn plus c. And there are three formulae that we need to know. So the first one is that 2a is equal to your second difference. The second is that 3a plus b is equal to term 2 of your sequence minus term 1. And the third equation that we use is a plus b plus c is equal to your first term, t1. And basically what happens is as you find a, you'll substitute it into the next equation to help you solve for b. Once you have b, you then have a and b. You'll substitute them both into the last equation to allow you to find c. Now, these three equations are not on your formula sheet. You have to know these, and they will ask you a quadratic pattern. So you need to know these three formulae. This is how you get Tn. All right, so that's just a very quick summary. I will do like a nice proper summary and put it on Classroom for you. I spoke about this already with you guys on Monday. I'm getting there in life. So I will do a summary for you guys, but this is like the basic overall sort of what you need to know when it comes to your sequences and series. All right, so I'm going to leave that up there. You can take a screenshot if you want, but let's do some questions. And then as we go along, you'll get the screenshot, but it's there. Okay, so if we have a look at this first question, we are told that we have an arithmetic series with a common difference of 4, 3x minus 1, and 2x plus 8 are the fourth and seventh terms of the series respectively. All right, now often, excuse me, sequences and series becomes confusing because of how the information is presented to us. So if you need to write out what you have in like mathematical language, for lack of a better description. So this common difference of 4 is telling me that the D value, so remember we're looking at arithmetic, my D value is equal to 4. This 3x minus 1 is my fourth term. So term 4 is equal to 3x minus 1. I'm just going to keep it in brackets for now. And 2x plus 8 is equal to my 7th term. And that is the information I have to work with this arithmetic series. Right, if it doesn't help you to write it in mathematical language, don't use it. I just often find that sometimes to take the English and put it into maths is quite useful. Okay. So the first question says, determine the value of x. Oh, I'm so sorry, Humelo, I did not see your question. I do apologize. Before I get into this, so Humelo's just asked, how do we find r? So this is for the common ratio. We will, I can't remember if there's a question, so let's just chat about this. So to find r, you would take any two consecutive terms and divide them. So you could take term 2 and divide by term 1. You could take term 3 and divide by term 2, term 4 divided by term 3, etc., etc. As long as they're consecutive and as long as it's the next term divided by the term preceding it or before it, then you'll be able to find r. So r, because it's a ratio, we have to do the division. Okay, sorry, Flamelo, I don't know why I didn't see that come through. I do apologize. Okay, so sorry, back to this. A asks us to determine the value of x. Now, guys, there are a few different ways that you can do this. You can do this with simultaneous equations if you wanted to, because of the fact that you know term 4 and term 7. But this is only worth 3 marks. And we know from our boot camp the other day, a simultaneous equation is worth like 6 marks. We don't really want to do 6 marks worth of work to only get a 3-mark allocation. So there has to be an easier way to do this. And there is. Because this is an arithmetic series, we know that every single time I move from one term to the next, I'm adding the same value. Okay, so what I mean by that is, as I go from term 4 to term 5, I'm adding the same difference 4. Term 5 to term 6, I'm adding 4. Term 6 to term 7, I'm adding 4. We know that term 4 is equal to 3x minus 1. And we know that term 7 is equal to 2x plus 8. We also can see, based on what I've just drawn, that if I go from term 4 to term 7, I'm adding the constant difference 4 times. I've added that d value 4 times in order to get from term 4 to term 7. Makes sense? 7 minus 4 is 3 times. So what we can do is we can set up a little equation. We can say, okay, well, if I go from term 4, 3x minus 1, and I add 3 of my differences, which is 3 4s, I will end up at term 7, which is 2x plus 8. And so now we've set up a little equation for ourselves that we can now go and solve. So we've got 3x minus 1 plus 12 equals 2x plus 8. And now when I go and actually combine my like terms, I get that x is equal to 8 plus 1, which is 9, minus 12, which is negative 3. Now, this makes a lot more sense for 3 marks than a simultaneous equation that typically is worth 5 or 6 marks, but this question is only worth 3. Now, I'm not saying you can't use simultaneous. You absolutely can, but it's going to be a lot more work for you than necessary. And so rather than trying to get into simultaneous equations, think back to what is this pattern? So that's why I asked you before we started, what makes an arithmetic series? What makes a geometric? What makes a quadratic? Because if you go back to that fundamental characteristic, it's going to help you answer the questions as you go along. So just remember for arithmetic series, you're adding a constant difference, which means that you are adding the same thing each time, and you can use that in your solution for whatever you're looking at. So particularly when they give you 2 random terms of an arithmetic or even of a geometric is a little bit harder, but particularly for arithmetic, as long as you know how many times you're adding that difference, you can set up an equation. All right, so like I say, that's 3 marks. 3 marks for understanding that you're adding the difference 3 times. I'm saying 3 marks, a mark for understanding your difference is being added 3 times, a mark for setting up your equation, and obviously a mark for x. Okay, so don't overthink it. I'm not saying that there aren't other ways to do it, but this is just the most straightforward way. Right, question B said, oh, sorry, yes.
Can you please repeat again?
Which part would you like me to repeat?
I don't understand why you put the 4 in the brackets.
Okay, so the 4 in the brackets is because I'm adding 4 3 times. Okay, so I add my difference 3 times to get from term 4 to term 7. So the 3 is the fact that I'm adding that 4 3 times. You don't have to set it out like that if you don't want to. You could have said term 4, 3x minus 1, and then you could have just added 4 3 times to show that would be equal to term 7. So you can just write the 4 out 3 times because that's what you did. But remember, the shortcut, if you're adding the same thing multiple times, is you multiply.
Okay.
Okay,
Thank you.
good. Right, question, ma'am, if you don't. Okay, so Layla's asked, if you don't get the value of x and a, does it affect how you would answer the remaining questions? Yes, but we're not going to penalize you further. So if you've done something a little bit strange or you've made a silly mistake in question A, you will lose marks in question A. But if you use that incorrect answer correctly in questions that rely on it, you can get full marks. So that's our continued accuracy marking. So now we are going to rely on my x value moving forward. And so I might lose marks in question A if I've done something wrong here, but I won't be penalized again later on. So yes, it does affect, but we won't penalize you multiple times for the same mistake. All right. Okay, guys, I'm just gonna, I'm gonna do this question, then we'll take a screenshot. All right, so the question says, calculate the first term of the series. Right, now, again, a few different ways that you can do this. Because you've now worked out that you're adding 4 each time, you could just subtract 4 3 times to get to your first term. Alternatively, you can just use your formula. So remember, Tn is equal to A plus n minus 1 times your difference. Because you've been given term 4 and term 7, you can use either one. It really makes absolutely no difference. But because we now know the value of x, we know, for example, that term 4 is equal to 3 times negative 3 minus 1. And so term 4 is equal to negative 10. And so we can now use that in our formula. So we would say negative 10 is equal to a, which remember is your first term, plus n, this was term 4, minus 1 times your difference, which was 4. And you can then go and solve that whole equation to get that your first term was equal to negative 22. So there's no reason to overcomplicate it. That's it. Again, you also don't have to do that. Because you've worked out that term 4 is negative 10 and your constant difference is 4, so you're adding 4 each time, you can just work backwards and keep subtracting 4. So 10 minus 4, negative 14. Negative 14 minus 4, negative 18. Negative 18 minus 4, negative 22. So you could also just work backwards from the information you've been given. But obviously, if we'd given you like term 48 and term 72, you don't want to be working backwards all the way 42 terms back to term 1. And so using your formula for Tn makes it a lot easier for you. Again, in this case, it wouldn't really matter because term 4 is not that far away from term 1. So it is easy enough to do. But just remember, you have formulae for a reason, and you are welcome to obviously use them. All right, so let's just take a screenshot of what we have so far, and then we will have a look at the next one. Lorato, I see your hand.
Hi, ma'am. So, ma'am, the 4 by the bracket in where it's substituted in the n minus 1 bracket, that is the position. No, ma'am. The other one.
Oh, this one.
Yes, ma'am. That is the
Yes.
position of the 4th term, right?
Yes.
Okay. Thank you, ma'am.
Okay, so guys, just in case we've forgotten with our formulae, and maybe you want to hang on 10 on your screenshots. So if we just pop back up to these formula over here, A represents the first term, and this is in both the geometric and the arithmetic. D for arithmetic represents your constant difference. And obviously we've said R is your common ratio. We've already said that. But then N is the position of your term. So term number 1, term 2, term 3, term 4, term 7. Whereas Tn is the value of your term. So we've worked out, say, for example, here, that term 4, which is Tn, has a value of -10. So n is the position, the first, the second, the third, the fourth, the seventh, whatever. Tn is the value of your actual term. And then we go from there in terms of our substitution. So that's why Lorato said here, in our formula, this is n, which is the position of your term. And because I was using term 4, I substituted in a 4. All right. Okay, I'm assuming we've got our screenshots here. Excuse me. Let's have a look at the second one. So the second one is asking us for the sum of the first 42 terms. Now, this is where our sum formula comes into play. Again, this is all on your formula sheet. I don't expect you to know this off by heart. But your sum formula is n over 2 times 2a. It's n minus 1 times d. Okay, now because I'm telling you how many terms I want you to add, this is n, right? So whenever we're talking about how many terms or the term number, first, second, third, whatever, that is n. So we want the sum of 42 terms, which means in place of n, I'm going to substitute 42, so 42 over 2 times 2. Now, a, remember, is your first term. We just wrote that down. And we've worked out that our first term is equal to -22 plus n, which is the 42 terms I'm adding together, minus 1, times my difference, which is that +4 I'm adding each time to get my next term. And then you just throw this all into your calculator. There is no need to do this step by step. I don't want to see you working out. I just want an answer. And so we get that the sum of the first 42 terms is 2,520. Right, so guys, in a sum formula like this where you have n and you have everything and you're actually just finding the sum, it's very straightforward. You substitute it in and you get your answer. Right, again, n is 42 because that's how many terms I'm adding. Remember, Sn means the sum of however many terms, 42 terms. And we get that if I added the first 42 of this series, I would get 2,520. All right. Any questions so far? This was like a sort of straightforward run-of-the-mill one, Lorato?
Ma'am, do you mind doing on like the side of the third question? Maybe if they had said the sum of the series was basically, I'm not sure how they would ask it for us to calculate n instead of them giving us a question where we have to calculate the sum of the first 42 terms.
I know exactly what you're asking me. There is a question like that, but there's sigma, so let's actually just do this. Okay, so let me just work out a quick sum so that I know it's going to work. Okay, so Lorato is basically saying if this question had been reworded to say, determine the number of terms to be added if the sum is equal to 26. Okay, I've just made it a smallish sum so that we can work with it. But this is sort of what Lerato is asking here. Now, in this case, I've said to determine the numbers. I also can't speak English, apparently. Determine the number of terms. I do apologize. This is what happens when my brain doesn't work at the same speed as my mouth. There we go. The number of terms to be added if the sum is equal to 26. So what we're now doing, because the question says determine the number of, what I'm now asking you to do is determine n. So that phrasing is saying to me, I want to know the value of n. So what we're going to do here is we still substitute in everything as we have, except now we know that the sum is 26. Now we've got 26 equals n over 2 times 2a, which is negative 22, plus n minus 1, and I'm solving for n, so I don't know what that is, times my difference, which is 4. All right, and now I have to solve for n. The first thing I always do is I get rid of this fraction, so I times both sides by 2. So that means 52 is equal to n, and then I simplify this bracket. 2 times negative 22 is negative 44. If I distribute this 4 into my bracket, plus 4n minus 4, and then I can simplify everything I have in there. That would be 4n minus 48. I then have 52 equals, and I distribute this in. You will end up with a quadratic here, so don't panic. And then we put it into standard form. So 0 equals 4n squared minus 48n minus 52. And then you need to factorize. Now, obviously, and particularly in these sorts of questions, if you can't look at that and immediately work out your factors, don't even waste your time. Just go straight into using your formula. Obviously, I've made up the question, so I know what my factors are. But like I say, if you don't waste time by trying to factorize, because this isn't what the question's asking you to do. The question is testing whether or not you can solve the equation to get n. So just go straight to your formula. Like I said, don't waste time. And so you end up with, if you were going to factorize, this can also all be divided. So that would be helpful to me if I actually did that. This has a common factor of 4, so I'm going to divide everything by 4 to start off with. Minus 12n minus 13, which means my brackets are n minus 13, n plus 1. And so n is equal to 13, or n is equal to negative 1. We know n has to be a natural number, and so n is equal to 13. And so we need 13 terms, or we need to add 13 terms in order to get a sum of 26. So like I say, you'll end up with a quadratic in a question like this, which you'll have to solve. And then you'll eliminate one of those answers that isn't a natural number, and you'll go with the n value that makes sense. All right, so that's how you would deal with it. It is often a question that we ask. And like I said, don't panic. You do get a quadratic. That is supposed to happen. Zlama?
Hello, ma'am.
Hi.
So if hypothetically they give us a question where they talk about a quadratic sequence, right? And then they ask us to find the sum, right? And then they've given us T2, T1, and the difference between T2 and T1. And then they also give us a difference between T3 and T2. And then the difference between the two are the same. And then they go on to, they further ask a question that, like, what is the difference between T70 and T69? Though we are not given the sum of the sequence, how are we going to find it?
Okay, so quadratic formulas, we don't work with the sum, so we can't ask you a sum question. I do think I know where you're heading with this, in that what they often like to do is they like to bring in the fact that, like you say, they like to say, what is the difference between, like you say, like term 52 and term 53 of your quadratic? And that's where we have to go back to the fact that the differences of your quadratic pattern form a linear pattern. So that's what we said over here. So the first difference form a linear pattern. So you now have to go back to your arithmetic formulas and use that in order to figure out what the difference would be.
Thank you, ma'am.
Okay. They do like to ask that one as well, so nice question. All right, let's have a look at our next one. So here we go. Here's a quadratic. The first term of a quadratic number pattern is 61. T of k, so the value of the kth term equals 4k minus 26 forms the first differences of the quadratic pattern. So this is exactly what I've said. Okay, before I carry on, Kelebogile?
Ma'am, I'm lost.
I need to know where you're lost.
The one that we're doing with the 26, I mean.
Okay, where exactly are you lost?
How did you get there? Is it minus 48?
Yes.
Ma'am, how
So
did you get it?
I got minus 48 from my like term. So in the bracket, negative 44, because 2 times negative 22 is negative 44. And then when I distribute the 4 in, I get negative 4. And negative 44 minus 4 gives me negative 48.
Okay.
Okay, so it's from adding my like terms.
Okay, ma'am.
Okay. Okay, guys, are we ready for me to move on to this next question? Just give me a thumbs up. Otherwise, I'm not going to move on. Okay, cool. Seems like we're all good. Right, remember, just ask as we go along. So I'm going to read the question again. So the first term of your quadratic number pattern is 61. T of k equals 4k minus 26 forms the first differences of the quadratic pattern. Write down the second and third terms of your quadratic number pattern. Before we even get to that, let's understand what this is saying to me. So we have a quadratic pattern. Okay, it's some pattern. The only information we've been given is the fact that my first term is 61. Okay, now when we go and work out our differences, obviously these will be different each time. However, remember, these form a linear pattern. And the rule for this linear pattern is given to me by tk is equal to 4k minus 26. So this first difference is my first term of my linear pattern. The second difference is my second term of my linear pattern. My third term, etc., etc. And so what I can do is I can use the rule that they gave me in order to go and figure out what those differences are. So term 1 would be equal to 4 times 1 minus 26, which would be equal to minus 22. So what that's telling me is that I need to say 61 minus 22 in order to get my second term. 61 minus 22 equals 39. So now I've got my second term. Then I go and substitute in for term 2. Term 2 is equal to 4 times 2 minus 26, which is 8 minus 26, which gives me negative 18. So this is telling me that I must subtract 18 now. 39 minus 18 is 21. And so I get my third term. And so I can use the rule that's been given to me to find my differences so that I can work backwards and get my quadratic pattern. And so here where it asks me write down the second and third terms of the quadratic pattern, I've done that. It's 39 for the second term and 21 for my third term. This is a 2-mark question. You're getting a mark per term that you write down, and that's it. So again, what you need to remember is that a linear pattern is formed from your first differences, and we wrote that down right at the start. And you can use that linear pattern, particularly if you're given the rule like we were here, to work out your first differences to then work with your quadratic pattern. Any questions?
I don't understand.
Okay, you need to tell me what you don't understand so that I know where I need to explain.
From the start, ma'am.
Okay, no, which part?
Ma'am, okay, how did you get the 39?
Okay, so as I explained here, remember this TK equals 4K minus 26 gives me the rule for my first differences. That's what it says here. It's the rule for my first differences. So I need to figure out what I need to add or subtract from 61 to get term 2. Do you agree with that?
Yes, ma'am.
Okay, so we can now say, well, that would be my first difference. So that would be term 1 of my first differences. So I can use the rule that I was given and substitute in 1 to work out my first difference. And that gives me minus 22. So what that's saying to me is I need to say 61 minus 22, and that will give me my second term, 39.
Okay.
And then I do the same thing with the next one. So now I want to figure out what do I need to add or subtract from 39 to get term 3. This is now my second difference of my first differences. So I can substitute in 2. And that tells me I need to say 39 minus 18 in order to get 21. And I can keep going with my first differences.
Okay, ma'am. Thank you.
Okay. So guys, it's really important that we remember our first differences form a linear pattern, and we can use that to work out our quadratic if that's what's asked of us. Okay, so the 39 and the 21 I got by substituting into my linear equation to work out what I was adding or subtracting from one term to the next. Right, any other questions? Oh, sorry, Lorato?
Ma'am, so basically if we're given like a pattern or linear equation basically that is formed using the first differences, we don't use the 61. We basically substitute like your 1, your 2 instead of the value to get like how much you need to subtract or add from that value to get your next number. Okay.
Yeah. So like I say, the first differences give you what you're adding or subtracting to your quadratic to get the next term.
Okay, ma'am. And then do we need to show like the calculation, or can we just say T2 equals to 39 and T3 equals to 21?
So in this case, because it was only 2 marks, you can just go straight to the answer. Obviously, you're welcome to show working out, but in this case, it would only be mark allocations for the answers.
Okay, ma'am. Thank you, ma'am.
Okay. All right. Flumelo?
Ma'am, can you please go up? I want to take a screenshot of oh no, I see it, ma'am. From the second question, the sum of the 42 terms.
Okay. Is this enough, or do I need to move up more?
No, that's fine. Thank you.
Okay.
Thank you, ma'am.
Pleasure. Right. So again, guys, first differences will tell me what I need to add or subtract to my quadratic to get each term. Right, so it says if the nth term of the quadratic pattern is given by Tn equals 2n squared minus 28n plus 87, calculate the value of the smallest term. So let's just establish what they're telling me. This over here gives me the rule for my quadratic pattern. So if I wanted to work out term 1, term 2, term 3 of the quadratic pattern, I would use this rule. Now, if you wanted to check, if you went and substituted in 1, so 2 times 1 squared, which is 2, minus 28 times 1, which is negative 26, plus 87, that gives you 61. That is the first term of your quadratic pattern. You could keep substituting in and substitute 2 and get 39 and 3 and get 21, etc., etc. But this is the rule for my quadratic pattern. Obviously, I don't need to substitute. I'm just saying that that is what it's giving me. So the question is saying calculate the value of a smallest term. So my first question to you is, what type of expression is this? Is it linear? Is it cubic? Is it quadratic? What type of expression is this rule?
Ma'am, it's quadratic.
Okay, good. It's quadratic. Now remember, guys, because it's quadratic, what that means is if you were to draw a graph of this pattern, you would have a parabola. Now, because this is a positive 2, it would be a happy parabola. And what it's asking me to do here is it's asking me to find the smallest term. So if we think of this in terms of our parabola, the smallest value of y would be at my turning point. And so what it's actually asking me to do is it's asking me to work with my turning point of my parabola. Okay, now what I want you to remember is that these n, so term 1, term 3, term 4, term 5, whatever, that is n. Those are your x values if you were to think of it in terms of a graph. The y values are your tn values, 61, 39, 21, etc., etc. Okay, so if we want to work out our turning point, we know that there's a little formula. You could use calculus here if you really wanted to, but we have our turning point formula. So if we want the x coordinate of our turning point, that's minus b over 2a. And we would substitute in minus b, so negative 28 over 2 times a, which is 2 times 2. And we get that n is equal to 7. So what this is telling me is that the 7th term is the smallest. Now the question said, determine the value of the smallest term. Remember we said here that Tn is the value of your term. So we now actually need to go and substitute in this value of n into my Tn formula. So Tn, remember, it was equal to 2n squared minus 28n plus 87. And we're going to substitute an n. So we're going to figure out what the value of term 7 is. 2 times 7 squared minus 28 times 7 plus 87. And we get that term 7 has a value of negative 11. And so the smallest value of this quadratic would be negative 11, which is term 7 in my sequence. Okay, so when they give you questions like this, think back to what your original expression is. Because it was quadratic, we are talking about your maxima or minima, and you can go and work it out from there. Like I say, you could use calculus if you wanted to. So if we remembered that our turning point is where our first derivative is equal to 0, you could do that. So sure, panic. Trying to think about how you would write this as the derivative. This shouldn't be so hard. Tn dash in terms of n is equal to 4n minus 28. That would be the first derivative of my quadratic expression that I was given. And remember, because it's the turning point, we make this equal to 0. So 4n equals 28. So therefore, 28 divided by 4 is 7. You get exactly the same answer. So we got n equals 7, same as what we got over there. We would substitute into our formula and we would get negative 11. So it doesn't matter which way you choose to do it. You can use calculus, you can use algebra, whatever you want. But the smallest term implies our minimum value, our turning point, and we would need to go and work it out. Because it said the value of the smallest term, it's asking us for the value of that specific term at that position. So we would have to also substitute into our Tn formula. Yes, whenever it says the smallest or the biggest, it would obviously depend on whether it was a positive or negative quadratic. Think back to your parabola and think back to what that means in terms of your parabola. Right. I know you need to take some screenshots, so let's just do this. So take screenshots of that so far, and then we'll have a look at C. Are there any questions thus far? Yes, Lorato, exactly. So then it would say, so let's say it was negative 2n squared, it would say calculate the value of the largest term. All right. So question C is now again bringing in some function type questions. And it says, a constant k is added to Tn such that all terms of the quadratic number pattern become positive. Determine the values of k. So again, this is a lot of information, but just bear in mind what you have just worked out. We have just determined that our turning point is at term 7 with a value of -11. So again, if you translate this to what it would look like on your graph, granted my graph is not going to be super accurate because that's not what is important right now. My graph would be something like that. Obviously, terrible parabola, but whatever. Turning point at 7, -11. And the question is asking me to make it so that all of my terms of my quadratic, so these are my Tn terms, so my y terms on my graph, are all positive. Now think about this. All of the values below the x-axis are where y is negative. All of the values above the x-axis are where y is positive. So essentially what I'm needing to do is I am needing to take this parabola that we have just got, so this parabola over here, and I am needing to essentially move it upwards so that all of the graph sits above the x-axis. That's what I need to do. So I need to take my graph from where it originally is, and I need to move it up so that all of my graph sits above the x-axis where y is positive. Okay, now if we sort of follow with that logic, what that means is that this turning point needs to move up above my x-axis because that turning point is the lowest, the smallest point on my graph. Now this is a distance of 11 units. So it needs to go just more than 11 units to all be positive. And so this value of k must be greater than 11 in order for all of my terms to be positive. Now, again, I'm very much aware of the fact that this is definitely a type of question that we often get asked in graphs. You'll remember questions like, I don't know, ax squared plus bx plus c equals k, determine the value of k in graph questions. It's the same thing. So you need to be able to translate your knowledge across sections. So quadratic functions in sequences and series and functions. Simultaneous equations in algebra and functions. Logs in exponential functions and finance. There is so much overlap and you need to be able to apply your knowledge to a whole bunch of different sections. So even though this is a series or number pattern question, we can apply knowledge that we already have from functions. All right, so k must be greater than 11 because it needs to shift up for it all to be positive. Right, that is the end of that question. So I'm just going to stop there for you to screenshot. If we have any questions, now's the time to ask. Otherwise, we're going to have a look at the next one. Rato?
Ma'am, so this isn't a question regarding C. It's more like when it comes to sequences. So, ma'am, if you don't mind, can you also include like our calculators? Because I know we could also use our calculators for like the sequences questions.
I don't really understand what you mean. What do you mean include your calculators?
Like, ma'am, maybe like the tricks. I don't even know how to put it actually.
Yeah, I don't really understand, unfortunately. There's no like tricks when it comes to this stuff on your calculator that I can think of. So if you can give me an example, I can do that, but there isn't really a trick on your calculator.
So
And the
even
only thing
sigma notation, ma'am, we can't use like our calculators.
Nope, there is no sigma notation available for you on your calculator, unfortunately.
Okay.
Yeah. So when there are tricks on your calculators, I'll definitely show you. But yeah, unfortunately not with this. All right, so now that Lorata's brought up sigma notation, it is something that we often struggle with. So I'm going to jump to a sigma notation question, and then we can come back if we've got time. So let's get to sigma. There it is. Okay, so sigma, like I said, one we often struggle with, but again, it's what I said right at the start. If we understand what has been said to us, it makes life a lot easier. Okay, so before we even look at the question, let's just break down what sigma notation is and what each of the little elements mean. So sigma notation, you have this weird looking E thing. That means sum of. You will then have a value at the top. I'm just going to make this up. Let's say 15. And you will have a value at the bottom. Let's say 1. That value can be anything, and we'll chat about this in a second. But you'll have a value at the top and a value at the bottom. And then you will have a Tn formula. So again, I'm just going to make this up, 2n minus 7. All right. Those are your parts of your sigma notation. And this is what it all means. So firstly, this number at the bottom means the first term we add from. So because this is 1, this is telling me to add from my first term. Term 1 plus term 2 plus term 3 plus term 4, etc. If that had been n equals 7, that's saying start adding from term 7. Term 7 plus term 8 plus term 9 plus term 10, etc., etc. The number at the top tells me where to stop adding. So this is the last term I add. So in this case, yeah, I would add from term 1 to term 15. Term 1 plus term 2 plus term 3 plus term 4, all the way to plus term 14 plus term 15. That is what that part is saying to me. The next little bit we have is our Tn formula. What this tells me is it tells me what my rule is and what type of series I'm working with. Is it geometric? Is it arithmetic? Now, this is useful to me because it allows me to work out different terms. So, for example, because I know what this rule is, I know that term 1 is equal to 2 times 1 minus 7, which is negative 5. I know that term 2 is equal to 2 times 2 minus 7, which is negative 3, etc., etc. And what that means is you can start to get an idea of what your series is. So sigma notation tells you that you are adding a specific series from term whatever to term whatever, top, bottom. Yeah, that gives you which terms you're adding of a specific series. So those are your elements to sigma notation. So if we now take that knowledge and we apply it to what we have going on here, this is telling me that I'm adding from term 1, n equals 1, to term m. So I don't know where I stop adding. I just know I stop adding at some point of the series 4n minus 19. Now this, because it's not a geometric, because it doesn't have an AR to the power n minus 1, there's no exponent. This is an arithmetic or linear series. All right, so I'm adding a series that has a constant first difference. Now there's an added little bit of information here that we didn't have there, and that's just by nature of the question. It tells me it's equal to 1,189. This is telling me that if I add terms 1 to m, remember I don't know what m is, of the series 4n minus 19, I get a sum of 1,189. So that is what that sigma expression is saying to me. And I feel like now that we know that, this becomes so much easier. I know I'm working with a sum, I know what my number pattern is, and I know I'm starting to add from term 1. Now, guys, if it did not ask this first question, so this first question is quite nice. It's leading us into where we need to be. If it had just gone straight to calculate the value of m, you always need to work out the first 3 terms. This is just going to help you because remember your sum formula of geometric or arithmetic involves an a value. You have to know what your first term is. Working out the first 3 terms just gives you an idea of what the actual pattern is. So we want to work out the first 3 terms, and I've actually already done an example of that on the side, but term 1 would be equal to, and I take my pattern, 4 times 1 minus 19, so that's negative 15. Term 2 would be equal to 4 times 2 minus 19, which is negative 11. And term 3 is equal to 4 times 3 minus 19, which is equal to negative 7. All right, so now we've got a general idea of what my series is. So it's negative 15 minus 11 minus 7, and we keep subtracting. All right, what we can now see is what my pattern is. So I start to get an idea of what I'm actually working with. Now remember, this coefficient over here actually tells you what your first difference is, but you can start to see it over here. From negative 15 to negative 11, I add 4. From negative 11 to negative 7, I add 4. So that's why that coefficient to my n value is positive 4, because I'm adding 4 each time. So now I know what my series is that I'm working with. I can go and look at my next step. Now again, sigma is sum of. So I have to work with my sum formula. Again, this is all on your formula sheet. This is not one you need to know. But the sum of an arithmetic series is S of n is equal to n over 2 times 2a plus n minus 1 times d. And now we start to substitute in the stuff that we know. Right, so, excuse me. I know that my sum is the 1,189. I don't know what n is. Remember, I don't know how many terms I'm adding. I just know I'm starting at term 1 and I'm adding all the way up until term m, but I've got no idea what that is. So n over 2. 2 times my first term, which we've worked out to be negative 15, plus n, again, I don't know what that is, minus 1, times my difference, which we can see because we've worked out the first 3 terms, is positive 4. Now, we've actually done a question like this because Lorato asked this earlier, but we've done a question like this in terms of solving for n. So again, the first thing I always do is I get rid of this 2, so I times both sides by 2, and that gives me 2,378 is equal to n times 2 times negative 15 is negative 30. I distribute the 4 into my bracket to give me plus 4n minus 4. And then I just neaten up that bracket. So 2,378 is equal to n. In my bracket, negative 30 minus 4 gives me negative 34. So 4n minus 34. And then I need to distribute in that n coefficient. So I'm going to end up with a quadratic. 4n squared minus 34n. And I bring that 2,378 over. Let's fix that. 2,378. Right, so this is a quadratic. Again, grade 12s, I would not even bother to try and factorize that, particularly because of this last term. That's a horrible last term. So I'm just going to use my formula. N equals minus b, so minus negative 34, plus or minus the square root of b squared, negative 34 squared, minus 4ac, so 4 and negative 2,378, all over 2a. You chuck that into your calculator and you get 2 values for n. N is either equal to 29, or n is equal to negative 41 over 2. Now we know n has to be a natural number, so we can get rid of that immediately. And so now we're working with n equals 29. Now what I want you to be careful of is this n value. And in this case, it doesn't really make a difference, but I'll explain when it does make a difference now. This tells me that I have to add 29 terms. Right. It doesn't necessarily say to me that I'm going from 1 to 29 terms. In this case, I am, but we need to be very careful. And I'll explain what I mean by this in a second. Right. So in this case, because I do start at term 1, I know that term 1 to 29 would mean I would need to add 29 terms. And so m would be equal to 29. However, and I'll write that down in a second. Let's just have a look here. If let's say, for example, I had, I'm going to do a very basic series, 2, 3, 4, 5, 6, 7, right? And let's say, for example, I only added terms 3 to 7. So 4 plus 5 plus 6 plus 7. My sigma notation would be that n is equal to 3 up to 7, okay, of this pattern n minus 1, n plus 1, so sorry. When you do not start adding from your first term, I've already explained this earlier, that bottom number will not be 1, okay? This top number tells me which term I stop adding at. So I add from term 3 to term 7. What we then need to bear in mind is that if you were to solve for n, okay, n being the number of terms that you add, you would get that n is equal to 4. You're only adding 4 terms, and we saw that here. 1, 2, 3, 4 terms are being added. And so to get any of those missing top or bottom values, there's a little formula which says top minus bottom plus 1 is equal to n. So let's say, for example, I did not give you the 7 and I asked you, let's say this was x, and I said solve for x. Your formula would say top, which is x, minus bottom, which is 3, plus 1 equals 4. And you would need to go and solve your equation in order to get what your top value would be. And so this little formula here is very useful when we do not start adding from the first term, okay? So when you don't start adding from the first term, very useful. This is not something we ask often, all right? But it is something that can pop up, and so it's just important to take note of. So for example, if I use that here, top minus bottom plus 1 equals n. My top value is the m that I'm looking for, minus the bottom value, which is 1, plus 1 equals 29, the n value I just worked out. Obviously, minus 1 plus 1 is 0, and so m is equal to 29. I'm adding terms 1 to 29 in order to get my sum. Now, guys, again, because you started at 1, because the sigma started at n equals 1, you don't have to do this top minus bottom plus 1 thing. That is not necessary. I'm just saying to you, you need to bear in mind that if you do not start adding from the first term, that is something you need to take into account. Right? Like I said, it's not something that comes up often, but every now and then we do. And so it's just important for you to know. So Layla, that sort of answers your question. You only need to use that formula if that bottom number, so just grab a highlighter. Oh gosh. So the bottom number is not 1. So this n, if that is not 1, then you need to use this formula. But if it is 1, you can ignore it. And the only reason is because we are essentially ignoring the first two terms and we're only adding a certain portion of our series. And so we then need to take that into account because the n value you find will be how many terms you add, not which term you add from and end at. And so we just need to take that into account. Right, but again, grade 12 is not something that comes up often, but something you do need to know just in case it does crop up. All right, so I'm just going to stop here for you to take a screenshot, and if there's any questions. Barato?
Ma'am, so basically, if it was a question whereby we had to calculate m, like here, this is like, okay, maybe let's say it's the n is not equal to 3. This is also when we would use the top minus bottom plus 1 to get the m value. So, ma'am, is it also possible for a question to give us the n value and to just, and also say n equals to, I'd say 4, for example, and then if the n value was 5, so would it be just a question where they tell us to calculate m for maybe like 2 marks, which would just be top minus bottom plus 1 equals to n, and then we just solve to find the m value?
They definitely could. Yeah, absolutely. It's more likely that they'll ask a question like this where it's calculate the value of m and you have to do the sum formula and all of that and then remember it. But they definitely could ask a standalone question like that, yeah.
Okay, thank you, ma'am. Then I also wanted to ask, because you put your values for the n, the one that is not equal to n in a fraction, and I put mine in a decimal, I won't necessarily get penalized, right? Okay.
No, because it's actually the value, it's the answer that you end up eliminating anyways. So it doesn't matter. And guys, on that, the only time you have to put your answer in a specific format is if they tell you to. So for example, in the algebra, when they say correct to 2 decimal places, if you leave it in surd form, you're going to lose a mark because you haven't done correct to 2 decimal places. Any other time, if they don't specify, we will mark you fraction, decimal, mixed number, whatever the case is, we will mark it right. I prefer my answers as fractions, which is why I write them as fractions. But unless it specifically tells you what format we want the answer in, we'll mark it correct. All right, so we've done sigma, we've done arithmetic, we've done quadratic. The only one we haven't done is geometric. So we're going to have a look at that now. All right, so question, okay, I know we're a bit all over the place, but it's fine. This is the joy of maths. Before I carry on, are there any other questions? And I do see a question has come up in the chat. So when n is not 1, we must start with the top minus bottom value. So, but no, we would do it the other way. So you would do the whole sum equation. Hang on, let me go back. Panic. So like I say, you will do the whole sum equation exactly as we did here. But then when you get this n value, you need to substitute it into this equation. And you would substitute it in for n. And then you would go and solve for the missing value. In our case, it was the top number that we were missing. And so we would go and solve for that. It's usually the top number that we're missing. And then you'd solve. So if, for example, the bottom number was 4, we would have m minus 4 plus 1 equals 29. And we'd go and solve that m is equal to whatever. All right, so we actually do the sum first. We get n, and then we substitute into the formula. Hope that makes sense. Okay, cool. All right, so if we have a look here, the first term of a geometric sequence is 81, and the common ratio is r. The sum of the first and third terms of the same geometric sequence is 117. Calculate the value of r. So again, let's not overthink it. Let's write down what we have. We know that term 1, which remember is the same thing as a, is 81. We don't know the common ratio, we just know that's r. And we know that T1 plus T3 is equal to 117. Now, remember that the formula we have for Tn of a geometric is a times r to the power n minus 1. And because we're working with term values here, we need to work with this formula. How do I know I'm working with term values? Because it says the first and the third terms. The first term is 81. All right, so we know that T1 is 81, so I can substitute that in immediately. I don't know what term 3 is, but I could use my general equation here, because remember the question says solve for R. So somewhere in my equation, I'm going to have R. So A times R to the power 3 minus 1 is equal to 117. And I've set up an equation in terms of R that I can now solve. So if I go ahead and do that, I get that 81 plus 81 times R squared equals 117. Remember, A is your first term, so that's why that's 81. The first term is 81. And we get that if we subtract 81 on both sides, you get that 81 R squared is equal to 36. If you divide both sides by 81, you get R squared is equal to 4 over 9. And remember, we don't want R squared, we want R. So we would square root, which means R is equal to plus or minus 2 over 3. Now, R can be positive or negative, so you would need to give both of those solutions. You would have to show me that you know it's plus or minus. And remember, when we square root, we have to remember the plus or minus. But this is just a basic exponential equation. This is something that we could have given you way back in like grade 10. It's an exponential equation, and you're solving for R. Right, so again, A is your first term. So that's why A. That is why I substituted an A for 81. Using my inverse operations, I subtracted 81 on both sides. 117 minus 81 gives me 36, and I was left with that 81 R squared. I divided both sides by 81, and 36 divided by 81 simplifies to 4 over 9. And so using my inverse operations, I was able to solve for R. Okay, so again, guys, when we look at something like this, there's a lot of information that we now need to translate. Don't panic. Go step by step, write down what you have been given in mathematical language. So in an equation, Tn, whatever, and you go from there. Any questions about this one? Okay. So if we look at question 5, this is also a geometric type pattern. It says, given the convergent geometric series. So again, before we go anywhere, I did say this earlier, but remember, a converging or convergent series is one where R is in between -1 and 1. So we can work out a sum to infinity. And if you have a look at question B, there's a sum to infinity. So R value is between -1 and 1. So given the convergent series, 3 to the power x, 9 to the power x, 27 to the power x, plus 81 to the power x, etc., etc. What do you notice about those terms? Does anyone notice anything about them? Okay, yes, multiples of 3. Can we think of it in terms of exponents? Okay, these can all be written as a base of 3. So 3 obviously is 3 to the power 1, so that's 3 to the power x. 9 is 3 to the power 2, so 3 to the power 2x. 27 is 3 to the power 3, so 3 to the power 3x. 3 to the power 4x, etc., etc. Now, the reason I'm asking that, or the reason it's important for us to be able to see that, is because in this question it says write down the common ratio in terms of x. Now, as I said earlier, if you want to work out your common ratio, you would take term 1 and no, you wouldn't. You would take term 2 and divide it by term 1. T2 divided by T1, T3 by T2, etc., etc. So term 2 is 3 to the power 2x, and term 1 was 3 to the power x. Writing those values as base 3s allows you to apply your exponent laws a lot easier. Exponent laws tell me when I divide, I subtract exponents. 2x minus x gives me an r value of 3 to the power x. And so that is what r is in terms of x. So just seeing that pattern, seeing that you can write them all as base 3s makes your life a little easier as you go on. And then ask me to calculate the value of x if the sum to infinity is a half. So our sum to infinity formula is a over 1 minus r. We know the sum to infinity is a half because it was given to us. We know that a is 3 to the power x, that's my first term, over 1 minus 3 to the power x. And we can go and solve our equation. Again, this will be an exponential equation that we're solving. And so it's going to take us back to, like I say, exponential equations. A little trickier, guys, when you've got one fraction and one fraction only on either side of your equation, you just cross multiply. So you'll multiply the denominator of 2 with the numerator on the other side and the denominator of 1 minus 3x with the numerator on the left. So we'd have 1 minus 3 to the x equals 2 times 3 to the x. And we can go and solve our equation from there, like I said. Like I said, it's an exponential equation, so we just need to think carefully about it. But we go from there. Now, this should take you back to your grade 11 exponential equations, in that on the left-hand side, you have 2 terms. The second in exponents, you have 2 terms you need to factorize. You cannot just start making exponents equal and all this nonsense. The second there are 2 terms or more, you have to factorize. You have no choice in the matter. So what I mean by that is, I can see that I've got a 3 to the power x and a 3 to the power x. If I put those terms on the same side, I can take out a common factor. So I'm going to have 1 equals, I'm going to bring this over so it becomes plus. So 2 times 3 to the power x plus 3 to the power x. And I can take out a highest common factor. I then have 1 equals 3 to the power x times 3. I'm going to divide both sides by 3. There's a few ways that you can solve this. This isn't the only way. And we get a third equals 3 to the power x. We know that a third can be written as 3 to the negative 1. And so x is equal to negative 1. All right, so this is like a grade 10, grade 11 level, grade 11, grade 10 is a little mean. Exponential equation. And this is where the exponents are tested along with that problem solving that we spoke about in algebra in your geometric number series. All right. And so, again, nothing was hard, nothing was new, nothing was unfamiliar. It was just a case of taking the knowledge that we have and applying it to the context of our question. But I'm not really sure where we got screenshots from. I think it was this though.